So here is a shortcut that you can use to find the Thevenin equivalent resistance for circuits that contain only independent sources. So if a circuit contains only independent sources, then there's a shortcut, and we can obtain the Thevenin resistance by deactivating all of our sources, and I'll explain what we mean. Basically turn them off, and what we're left with is a resistor network, and we just simplify that resistor network. So let's talk about what we mean to deactivate a source. So to deactivate a source, set its value, so the voltage or the current, set its value to 0. So let's have a look for a voltage source. So if we have a voltage source, so this kind of circuit symbol, then to deactivate it, we set the voltage to 0. Okay, so if you have a voltage source with 0 volts, that means that the terminals are shorted together. If there's 0 volts across those terminals, then they're part of the same node. So this is actually short the terminals. Right, so if we had our original voltage source which has these little terminals on it, then what we do to deactivate it is short them together. So it's just a little wire that connects. So we replace our voltage source with a wire that connects them, and that deactivates the voltage source. 0 volts between those two nodes. If on the other hand we have a current source, then it will work out a little bit differently. So for a current source, what we actually do with that is we set the current to 0. All right. What does it mean if there is no current that can flow between two nodes? Well, it means that we have an open circuit. So open the terminals. So we would take our current source, which had a node on each side, and we would replace it with just an open circuit, basically just our two nodes totally disconnected. So current source, we just disconnect, we kind of unplug it from the circuit. So let's do an example. We've got here a network, and we would like to calculate the Thevenin equivalent looking into the terminals labeled A and B. So we need to deactivate the sources. So I'm going to redraw the circuit with the sources deactivated. So redrawing, on the left-hand side we have this voltage source. We set it to 0 volts. 0 volts means short circuit. And so I just replace that one with a line. I will continue drawing. So we had a 5 ohm resistor, a 20 ohm resistor. Then there was a current source, and remember, current sources just get replaced by an open circuit, so kind of nothing there. And that was a 4 ohm resistor, and then there were our terminals. So we're just left with a network of resistors that we then need to simplify. So looking into these terminals, A and B, I recognize that I have a parallel combination of resistors here, so I will need to simplify that parallel combination. So calculating that, 5 ohms in parallel with 20, ohms, that will be the product divided by the sum, so that is 5 times 20 divided by 5 plus 20. So that will be 100 divided by 25, which is 4 ohms. So we have 4 ohms is the equivalent of these two here in parallel. So I can redraw my circuit. It's a little bit simpler. Now I had the 4 ohm resistor that I haven't touched yet, 4 ohm resistor, and then that one is connected through the equivalent of that right hand side, which was just 4 ohms. And so the total equivalent circuit looking into these terminals is therefore 8 ohms. So this is just 4 ohms plus 4 ohms will give me 8 ohms. So the equivalent circuit that I have is just an 8 ohm resistor. And so this tells me that the Thevenin resistance, so RTH, the Thevenin resistance for this network is simply 8 ohms. So you see this is maybe a slightly faster way or simpler way of finding that Thevenin resistance. To get the Thevenin voltage, I still need to know the open circuit voltage, so I still need to do a bit of circuit analysis. But this one allows me to get the resistance, at least using a simpler method. So to remind ourselves of the strategy, we deactivate our sources, so voltage sources become a short, right? 0 volts, it means the terminals are shorted, whereas a current source becomes an open circuit. 0 amps means no current can flow, means no connection.